Welcome to my projectbazaar.com.
Now we discuss about the product for energy efficient programmable MIMO decoder accelerator chip in 65 nanometer CMOS. Next we see the abstract for the product. Today most high speed wireless communication standards adopt both multiple input and multiple output and orthogonal frequency division multiplexing operation. This applies to small scale wireless data networks such as 802.11 nano wireless LAN standards as well as large scale cellular systems such as WiMAX, and long term evaluation include the enhanced versions. In OFDM, a wideband frequency selecting fading channel is divided into several independent narrowband flat fading subchannels. In addition to construction of two subchannels at the transmitter and to receive the receiver hardware is required to independently perform channel processing, estimation and equalization for each and every one of these subchannels. Similarly, MIMO operation requires parallel processing for multiple data streams as the transmitter and more importantly at the receiver, where the MIMO decoder is notified for being one of the most processing in intensive block. A MIMO decoder is a receiver component that separates the NSS transmitted data streams for the signal received in N receiver receive the antennas. Most of, if not all of MIMO decoding operation is a matrix and vector intensive for OFDM system. This processing repeated for every subchannel. This results is the processing bottleneck as a sort of MIMO decoding architecture. This paper presents a energy efficient programmable hardware accelerator that target multiple input multiple output decoding takes of orthogonal frequency division multiplexing system. The work is motivated by adoption of MIMO and OFDM by almost all existing and emerging high-speed wireless data communication systems. In MIMO architectures, we developed in 4x4 QRD decomposition and 4x4 singular variable decomposition and 2x2 minimum mean square error detecting. Despite the programmable of nature of our design, it delivers the energy efficient and reduced hardware complexity MIMO FDM architecture. This paper presents the VLSI implementation of architecture discussed the implementation of trade of the minimum overall energy consumption of resulting the accelerator chip without sacrificing the programmability of MIMO decoding architecture. Next we see the flow diagram for the product. First the data input and data input to apply the binary input to process the MIMO decoder architecture. Thus the processing input to be applied the processing core architecture. The processing core architecture mainly consider the 5 arithmetical unit: addition, multiplication, division, rotation and the division unit. The rotation unit mainly based on Cordic based rotation architecture and the vector and general based architecture to be placed in our rotation architecture. The multiplication and addition architecture mainly consider the CSI based addition architecture due to the carry propagation reducing time process. Thus the instruction input to be what are the output are displayed by the processing output results. Thus the apply the instruction input and to control the controller architecture which input to be selected to be maintain the instruction input and processing core architecture. Thus the processing core architecture results to be displayed based on our controlling functions. Thus the control to be selected the what output to be passed on our architecture results. Thus the two operand to be passed in our the processing core architecture. Thus the processing core results to be applied to the memory oriented process. Thus the data core output process is the memory orienting architecture results. Thus the data output memory to be passed in the final results. This final results mainly based on our data output results for the required any type of arithmetic result for our two operand architectures. This data output memory results to be applied the final architecture results. This process mainly considered for simulation synthesis for overall MIMO decoding architecture for our the accelerator MIMO accelerator designs methodology. Next we see the final output for the product. First open the MIMO ISC Xilinx project. Thus the ISC project to be open for Xilinx 14.2 version results. Then to select the simulation results and to select the MIMO over OFDM processes, then to simulate the simulate behavioral model in our architecture. This model to be displayed the iSIM project navigator. This navigator mainly used to simulate our the MIMO decoder architecture results. Just we apply the input binary data for our simulation process. Just we input the clocking signal and to select the any of the address location for store the data input and data output results. Then the writing sections to be activation. Then the instruction input to apply the any one of instruction process. Then to pass the data for record any 8-bit results. That's the imaginary input data. The rotation mode based on our Cardic based rotation architecture, just we theta and pi section to be applied for our input. Then to run, then apply the clocking signal. Then to write the data for our architecture result. Then to read the output results. Then to read the output data results for a required instruction input for our the simulation architecture results. This is our MIMO decoder architecture simulation result. Then to close and to implement the implementation result, just we open the view RTL schematic diagrammatic representation. This add and create schematic. This is our architecture for RTL diagrammatic representation in our MIMO decoder architecture. This architecture mainly used to what are the logical blocks presented in our MIMO decoder architecture. Then open the technology diagram. This technology diagram, what are the lookup table designs and input output wire connections, then bounded input outputs, then buffer connectivity for our MIMO decoder architecture. Then open the design summary process. The design summary process to create the synthesis report results. This result used to how many area occupy for a MIMO decoder architecture and overall architecture, and time allocation for a MIMO decoder architecture to be displayed for our architecture process. This is our device utilization process, and this is our timing summary for our the processing architecture. This is the minimum period and frequency level, then the latency level for overall architecture for MIMO decoding architecture results.